All right, so we finally make it to the laboratory report and the data sheet. And if you've opened this up and if you've looked at it already, if not, let's take a look at it together. Woo! How many pages of that was? What? Did that just sound like Yoda? Folks, this is a very lengthy 2-day event that we are going to accomplish in our lab, and it looks very deceiving because it looks like a lot, and actually it's not. It's a mixture of lab directions that we have to follow and areas that we can record our data in, and then there's going to be sections on a second day, and those second day is a place that I can do some of the calculations and see if this batch actually passes quality control standards. So that is the intention of this lab. And because it's your first one that you're seeing this way, we need to go through the motions and we need to make sure that you can kind of follow suit, read the directions, include what you need to include, write down the data, print off your receipt tickets if needed, attach your batch report to it, and then figure out if the batch of samples that you ran, can we pass those fully? Can it 100% go as far as yep, we did our job, everything was okay, everything went smoothly, there were no issues at all. Release the Kraken! So release the data. Notice it says on the first page, on the very first day, you're going to need a stock solution that you're going to have to make, and that is our kind of standard stock solution that we've done. And then that's going to have to be weakened down, and that's going to be our PDS that we talked about in Module 3. Then it looks like number 3, we need some blanks, and quantity 8. Number 4, it says initial calibration verification, and that is an ICV that we've now talked about. We've went through that table. Next one is a continuing calibration verification times 4. Now, you might not need all 4, but we definitely need one in the beginning because it tells us to do that. We need one every 10 samples because it tells us to do that. And we need one at the end because it tells us to do that. So if we have a minimum of 3, then if our group brings in more than 10 samples, then guess what? We run 10 samples, do a continuing check, run another 10 samples, do a continuing check. So this is just kind of helping make sure that you have enough in the very end. All right. Number 6, it says quality control, and it says prepared by instructor. We're going to run this in duplicate, so we're going to run that twice. Number 7 says a spiked verification. So this is a spiked fortified sample. That's what this is. So I need a sample first, and then I'm going to spike that sample to make sure that my signal and my concentration did go up on the report sheet. Number 8, I also need to bring in some samples, and they can be samples from anywhere. So what's going to happen on the first day is that you're going to be given the opportunity to get some bottles in our lab arena, and you can take as many bottles as you want to take. We need around 250 milliliters of sample in total for one round of analysis. Actually, that 250 is way more than enough for one round, but we're just going to say 250 minimum. That way, if you spill some, if you knock the container over, you might have some left over in that container to actually recover and actually use. But 250 mils. And we're going to split that up into 2 portions because everything's got to be ran in duplicate. Our TOC vials that we are going to be using in the lab will hold around 40 mils. We're going to fill these about 2/3 full at least. So 2 containers is going to be 80 milliliters minimum that you need to bring in. So again, that's why we do 250, because that way if you do need extra or if you need a rerun or whatever the case might be, you've got it there, it's ready. That drinking water can come from anywhere. So some people will do their tap water just because they want to know more about it. Some people will bring in 2 samples, and that will be from the fridge. because their refrigerator has a built-in filter maybe, and they want to see, is that filter doing something that it's supposed to be doing? And then they'll compare that to the tap water that comes out of their faucet. That's not a big deal either. If you want to go through that motion, you're more than welcome to do that. We've had some people in the past that have had some filter systems on their shower heads, believe it or not. So if you want to, you can take some tap water and then catch some of the water from the shower head and see what's present and see what's there. That's not a big deal. A Brita filter, some kind of filtration system that is on your faucet in your kitchen. You can do a before and after that way as well. You can go out of your home and you can go to the outside water spigot and you can crank that sucker open and catch some water, bring that in. If you've got a nearby river, lake, or stream that you want to bring some water samples in, that is not a problem either. So go catch it. Just be really careful that you don't fall in. If you do fall in, I wish I was there so I could see you happen. But, you feel whatever you want to bring in, feel free to bring what you want to bring and however many you want to bring of it. That is the magic of this lab. So it becomes a little personal now. So this data means something to you. Very, very important. All right, so the first one is 7.2. And this is the production of the potassium hydrogen phthalate. And potassium hydrogen phthalate, also known as KHP, CTC 114 people, where have you seen KHP before? Oh, well, can you figure that out? I hope so. Actively thinking. But 7.2 is potassium hydrogen phthalate, and we're going to use this and we're going to make our own standard instead of ordering it. We could order it. Absolutely. I can order it all day long, but I'm going to get you to go through the motions of making the standard yourself. So it's going to tell you how much to weigh out. And on this form, it's going to say, is the 1000 ppm already prepared? Most of the time we're going to hit no, because I'm going to get you to do it. Then it says, if yes, complete the table below. Manufacturer's name, the lot number, and the concentration printed on the bottle. These are going to be NAs for us, especially if we make it ourselves. I go to the balance, I weigh out some stuff, I make my own solution. So those are going to be NAs. You should never leave blanks blank. You should never put a line in them. You should always write something in them, and that is NA for not applicable. Next it says, if no, you need to prepare your own solution. And A says dissolve 0.2128 grams of KHP that has been previously dried in distilled water and then dilute to 100 mils in a volumetric flask. All right, so what's happening here is that we normally have pre-dried the KHP for you, and you will find our KHPs in the desiccators that are on our back wall. And they'll be in small little Petri dishes, so that way you can grab just a small Petri dish, take it to your balance where you're going to be measuring it out, use it, but return it back to the desiccator, please. So we have pre-dried them. The water vapor is now off. There's no water mass that's associated with it. And we are weighing 0.2128 grams of dried KHP. Under section A, it says, what is the amount? So you write your number here. What is the final volume that you diluted to? That would be 100 milliliters if you use the volumetric flask. Attach receipt ticket. I hope so. I hope our balances have receipt paper that's printing off your tickets. So that way there's proof, there's documentation that's there to say, yep, this is exactly what I did. And then B says, well, calculate your actual concentration. There is a chance that you did not weigh out 0.2128 grams perfectly. No one says that you have to, by the way. No one says that this is a thing that you're going to have to do. So when I dissolve whatever I dissolve, I need to calculate the actual legit concentration that I have made. And I know that I'm not going to get that target value. I'm not going to waste my time to get that perfectly done. So the way that you do this, you're going to take 0.4705. You multiply by the actual weight that you have measured with the balance. You then multiply by 1,000, divide it by the actual volume. And the actual volume is going to be 100 because you made a 100 milliliters of that solution in a volumetric flask. That is a very shorthanded way to calculate the concentration in part per million which is milligram per liter, for your prep based on your mass that you did in the laboratory for that day. Notice it says the value should be between 995 to 1005. If not, you need to reweigh and you need to remake the standard. So yeah, we kind of often say you don't need perfect. You don't need 0.2128, but you want to get close. And you want to get close enough where you get that target concentration range of 995 to 1005. If you weigh out way too much, or if you don't weigh out enough and you shortchange yourself, you will not be able to get in that target range that we are after for the lab experiment. Next up is a comment section. And this comment section is just for you to write down something. So, what did you notice? What were the observations of the crystals? Were they clunky? Were they crystally and shiny? Were they dingy? Was it brown? Was it white? Was it purple? Those are the types of things that you would want to write down in the comment. The other things with the comments is, maybe the balance that you used. If they're numbered, which balance did you use? It never really asks for that on the sheet, but these can go into a comment section to let someone know what you actually did when you weighed out something and you did this measurement in person. Next up is the analyst name. So the analyst name you would want to print or you would want to sign it to say, listen, I did this. I'm signing off on it. This is legitimate. And then it says, well, give me a date. So you're going to write the date here. And then it says, give me a time that you did it. So you're going to write the time there. And then the signature of the supervisor. So this is for someone above you that will go in and look at this form and they will say, is everything present? Did you fill out the form completely? Yes or no? Did you leave out important pieces of information? Did you attach the receipt ticket? And it is a way for that reviewer just to kind of go through and put their eyes on it. If they have done this already, because there's tons of forms, then they are going to sign it as well. And then that lets them know, I've already looked at that form. I know it's legit. I know everything is there. And we move on to the next form that we now need to review. All right, so that's going to be the purpose of the very first page that you are seeing in this lab document that's quite lengthy. Next up is 7.3a, and it says now you need to make a potassium hydrogen phthalate, KHP, dilution standard. So that what we just made was way too strong. It was 1,000. We need to weaken this down. So it's going to tell us how to do this. So 7.3a1 says obtain that 1,000 ppm from up above. Then step 2 says using a volumetric pipette, deliver 10 milliliters of that 1,000 into a 200 ml volumetric flask. Number 3 says dilute to the line with water. Number 4 says mix it really well and transfer it into a bottle if we ask you to. A lot of times we skip this step just to save on the glassware. But if there's amber bottles that's out there because we know this is going to stay around for a little bit, then we're going to give you those amber bottles. If not, leave them in the flask or put them into a container that we provide. And then step 5 says label it as PDS-1 with your group initials and put it in the refrigerator at 4 degrees. So preservation, again, is very important. Using the dilution equation, it says calculate the concentration that you have just made. So here's a hint. Here's the dilution equation. If you are not in CTC 150, that's not a big deal. We'll walk through the motions right now. C1 is the initial calibration standard. This is a 1,000, or really whatever you made when you do that calculation on the previous form. Whatever value that was, that's the value that's going to go here. Next up is V for the volume. So you have pipetted 10 milliliters of that. That's what it said in 7.3A2 right up above you. That is exactly what it tells you to do. Pipette 10 mils of that. So I've got 10 mils of that stuff. And I'm trying to calculate the new concentration if I prepare 200 milliliters of that standard. So there's my setup. That's what C2 represents, the concentration that it ends up being, your final one. And then your V2 is the final volume that you have prepared, and it's 200 in this case. So I'm going to take 1,000 times 10 and hit equal. Do that in one step. And then I'm going to divide by 200. When I do that, that will give me an answer. And that answer is part per million. The reason is because 1,000 is part per million. So that concentration will match, and that means my answer will also be in part per million. If it was 1,000 molarity, my answer is in molarity. If it was 1,000 normality, my answer would be in normality. If it was 1,000 part per billion, my answer would be in part per billion. The units have to match on both sides of this equation. All right, so just as before, there's an area here for comments, for you to write down things. Did it get cloudy? Was it clear? Did it look like water? Did you see any floaters? What was going on at that time? So this is a place for you to jot down some notes to let someone be aware of what was going on at that time. Your name is going to be required because this is a separate form. The date and the time is going to be required again. And just as before, a supervisor will look at this form, make sure that everything looks legit, that your calculation is correct. And then at the very bottom, they sign it and we move on to the next form. All right, so the next one, 7.4 and 7.5 from the original method. That's where these call numbers are coming from. Says carbonate by carbonate stock solutions and standards. Well, remember what I did? Whoop, 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 whoop. We don't need to worry about that. We're skipping over that. We're not going to include that in our method. We're not following it to a T. So we're just going to kind of save you some trouble, make less samples that we have to run. I think everybody's happy. Next up is section 7.6, and it says a blank. A sample of deionized water from the lab will serve as the blank. Deionized water has been used to make all the standards in the lab setting. And it gives me a couple of directions. Obtain deionized water. Fill a clean TOC sample container at least 3/4 full with deionized water. Repeat 7 more times. You should have a total of 8. Please label them as DI 1, 2, 3, 4, 5, 6, 7, 8. Put your initials on there so we know who goes what. Now 7.6 is done. Just as before, write some comments in there. Where did the water get obtained from? What room number? Was it cloudy? Was there floaters? Did you see anything in there that looked odd? Write your name, date it, time it, and someone will review that form and sign off, meaning they double checked, yep, you did 8. Sure enough, you did 8. I count them, I see them. Great job. I'm going to sign off. Next form is the quality control parameters, and this is our initial calibration verification, ICV. It says the sample should be a known concentration by the analyst. The solution will need to be prepared from a separate source than the ones in 7.2 and 7.3. So Q11 says obtain a pre-made 50 ppm solution. So this is not the 50 that you have made. You've made your own. You've made it from the stock. That is kind of how this process is going to work. With the ICV, we need to double check that calibration that's getting ready to be made and generated. So you can't check the calibration with something that the calibration was made with. That does not make any sense. So we've got a ordered bottle of 50 ppm that's in the lab. You will find this up in front. That is the bottle that you will use. You are obtaining it from a different source, and that source that is independent will be analyzed against the calibration curve that you will run, and we want to make sure, is this what it's supposed to be? Well, 50 ppm is too strong, so we're going to have to weaken it down to make it kind of fit the window that we're going to be running with as far as our samples and our calibration standards are concerned. So the directions are going to tell you what to do. Take 7 milliliters by a volumetric pipette, and then you're going to dilute that to a total of 50 milliliters or sorry, 7 milliliters of the 50 ppm, and you're going to dilute it to a total of 100 milliliters at the very end. You're going to mix it really well, and then if we give you some type of container, pour them into those containers, pour them into the TOC sample vials or containers, whatever floats your boat, it does not matter. We'll let you know what to do on that day when you come in. Then it says calculate what this concentration should be, and you're going to need the dilution equation in order to do that. So place a sample 3/4 full into a clean TOC sample container and label it as ICV1 with your group initials. All right, so here's the dilution equation again. My initial concentration is 50, and these directions have told me take 7 milliliters of that. We want to calculate the new concentration that I'm ending up with, the final one, and we have made 100 milliliters of that solution. That's what those directions told me from up above. So I'm going to do a little bit of math. I'm going to take 50 times 7, hit enter, get a value, get a number first, and then you're going to divide by 100. Whatever number you get, that's the number that's going to go here for part per million. That is the target concentration that you should be seeing on the report when we start obtaining data. Just as before, comments are there at the bottom. Sign it, date it, time it, and then someone's going to double check your math, and they're going to be like, yeah, that looks good, great job, and they're going to sign off. All right, so that's that form now taken care of. ICV, check. Next up is a quality control parameter, and these are the CCVs, so the continuing calibration verification. The sample should be a known concentration by the analyst. The solution will need to be prepared from a separate source than the solution in 7.2 and 7.3. Very similar to an ICV setup, right? The solution should have a different concentration than the ICV. So it gives me directions on what to do. Step 1, obtain that pre-made 50 ppm, that bottle up in front. Using a volumetric pipette, deliver 6 milliliters of that 50 ppm, place it into a 50 milliliter volumetric flask, add water, dilute to the line, give it a really good mix, take a TOC sample container, fill it 3/4 full, put a lid on it, put your initials on it, and then repeat that 3 more times. So I do want to say, though, in this sample preparation that you are doing with the continuing calibration verification, CCV, these containers, as I told you before, the TOC vials that you're going to be using will hold about 40 milliliters, and you're making 50 here, and you're transferring about 3/4 of the way full. So what this means is that if we've got to prepare more than one of these, then I need to repeat this process more than one time, of course. That means I probably need to go back and do another 6 mils of the 50, another 6 mils of a 50, another 6 mils of the 50, and I need to prepare 4 of these 50 mil samples in the laboratory. And then those will end up transferring over into the sample container. So I could do it that way, and I'm going to make you do it that way because I want you to practice on your volumetric pipetting skills. You could just times this by 4. So you could be like, hey, well, why can't I just take 200 milliliter volumetric flask? Well, you could. And then why can't I just do 6 times 4, which is 24 milliliters volumetrically pipetted? Well, we don't have a 24 mil pipette. We've got a 20 mil volumetric and we've got a 4 mil volumetric, but by the time that you use multiple volumetric pipettes this way, you're opening yourself up to more error. So we just don't kind of like that when that begins to happen. But I think that for practice purposes, making you do this 4 separate times is going to be in your favor in the long run. Right. Just as before, down below, we got to calculate what these CCVs are supposed to be providing us as far as the concentrations are going to be concerned. So the initial concentration is going to be 50, and it looks like I should be measuring out 6 milliliters in total, right? If I go back up to the directions, it says pipette 6 mils. And then I need to calculate the new concentration of what I'm making if I go to a total volume of 50. All right, so just as before, I'm going to take 50 times 6, hit enter, get a number, and then I'm going to divide by 50. And then whatever value that is, that's the value that goes onto the blank right there. Okay, now the reason that I'm saying it that way with every single one of these is if you're not careful, it's going to kind of just do this all in one big chain. And it might work out in your favor sometimes. Absolutely, I'm not saying that it's wrong every single time. But there are times where things have to be stayed together, and you want to make sure that those things that are grouped together stays together before you go back in and do the next operation. That was called the order of operations in a math class, if you've had to go through one of these before. So 50 times 6 is together on the left-hand side. Do that first, hit equal. Get a number, do them in baby steps, and then divide by 50, and then that way you get an answer here in the very end. Again, just as before, write comments, things that you see, things that you don't like, sign it, date it, time it, and then let a supervisor sign off, double check your calculations to make sure that they do work and that they do make sense. Next up, the other form that we're going to see next is a quality control sample. This is our formal QC. So it says the sample is an unknown concentration that's going to be provided to you. You do not know what it is, and we're going to be running it. We're going to be analyzing it. We know, meaning instructors know what we've provided you, but you do not. So you're going to just take some of the QC, add it to sample containers, and we're going to analyze it, and we're going to run it. It says transfer a portion of the QC sample into a clean vial, label the vial as Q1, and then repeat it again, and this will give you a duplicate. So we need 2 of these QCs. So 2 TOC vials that we will be analyzing with our samples. Next up, it says our samples finally need to be ran in duplicates. Please label them SMP with a number afterward. First step says obtain a sample. If a sample was submitted on the same day, well, that will be in your lab area. If not, we've got some backups. Second step, samples are probably not going to be analyzed on day 1. If we already have samples on day 1, then we are going to have to preserve them, and sometimes we get you to go through that. So we are going to pH these, and we're going to pH them down to a 2. Notice it says add some acid, pH it, record maybe the pH that you have. Next step, transfer a portion of that sample into a clean container. Label it as your sample number -1. Then pour some more into a second container. Label it as sample number -2. Add your group initials so we know who they belong to. And then repeat for all the samples that are brought into the lab environment. There is a chance that we will skip this, depending on the year. And we will definitely skip it if we tell you ahead of time, listen, today we're making standards, we're getting everything organized, ready to run. The next day that you see us, we want you to bring samples. Collect those samples fresh, preferably the day that you come to campus. If you collect them that day that you come to campus, there's no need for us to pH them and go through this mess. Just bring them on in, and then we will take over from there, and we'll go ahead and analyze them. So we will not acidify them in order to preserve them. If we bring our own samples in, we will also try to do that more or less for the most of the time. We will try to go to the river. We will get them that morning. We'll have them ready to go by the time that you come in the afternoon. Next up is a spiked verification. This spiked verification you cannot do on day 1. All right. And the reason is because this is a spiked verification of a sample. So we're making sure that when we add TOC to a sample, that sample's value does in fact go up from what it ran. So if I run a sample and that sample gives me a 5 part per million value, and let's say I add a 1 part per million to that sample, then that report better be showing me a 6 for the spiked verification. It allows me to know, okay, there's more of it, so therefore the signal goes up, the machine sees that increase in signal, the machine gives me that higher concentration, and it is what is expected. So that analyst, whoever you are, will be doing the spiked verification. You need sample, though, in order to do it first. So the spiked verification typically is going to happen on day 2. You need your samples first before you can do that. On that day, when you do the spike, the directions are going to tell you what to do. Obtain a pre-made 50 ppm, just as before. You're going to transfer a portion of your sample, not water, not water, not water, not water, not water, a sample. The sample is going to go into a 50 milliliter volumetric flask. We have to be very particular with the volumes that we're using because we're trying to calculate the exact concentration that this sample should be after I spike it, after I put the alcohol in the punch. So volume is very important. So samples are going to be used. You keep your hands off of the DI water sprayer. That is not what goes on here. No DI water sprayer, no DI water faucet, nothing. No. It is sample. Have I made that point clear? So some of the sample goes into the 50 ml volumetric. Then using a volumetric pipette, we're going to do 1 milliliter of the 50 into that 50 ml volumetric flask, and then we're going to dilute to the line. But when we dilute, alert, 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 no DI, no DI, no DI, no DI, no DI, no DI, no DI. It is all sample, 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 sample. We're spiking a sample. Sample is what needs to go into the volumetrics. So then we're going to pour that into our spiked verification. This is where we deviate a little bit. It does say that a lot of our quality samples should be ran in duplicates. We're not going to run this in duplicate. We're going to do one of these and run it and call it a day. Make sure you add your initials onto the SV- the number, and that number is supposed to represent the sample number that you have allocated. So if you chose sample number 3 in your group to do a spike, you're going to label this as SV3 with your group initials. That's how that's going to work. Okay. That way we know what you actually spiked. Next, it says calculate the increase of the concentration based on what you added. All right. So again, the way that we do this is CV equals CV. So we started with a 50 part per million. We took 1 milliliter of that and we spiked a sample with it. What is the concentration if we go to a 50 total volume, right? That's what this is all about. So 50 times 1 is 50. And then we're going to divide that by 50, and our concentration is a 1. So if you follow these directions up here, this should add a 1 part per million on top of that sample, however much that sample reads. If it ran 4, the spiked one should be 5. If it ran 23, the spiked one should be 24. You've added 1 part per million extra to the sample by doing the spiked system. This is also known as the Laboratory Fortified Matrix, LFM. That is how we refer to it in Lecture 3. Oh, I learned something. So here is LFM. Ayo. Comments again. Write down what you think is important. Sign it, date it, time it. Supervisor will look at this information, make sure that everything is complete. We sign off on it, and you're good to go. So on the next set of the pages, you're going to see everything that happens on day number 2. So now up until this point, I've got my samples brought in. My standards have been made on a previous day. They're ready to go. I'm now going to kind of start the analysis portion of the lab activity, and it's going to give you a little bit of information on how to do this. So in the next video, we'll pick up from here. These are things that happen on day number 2. What are some of the things to look for? What should I be aware of? And then maybe how do I process some sample data entry in the backside? So come back. We're almost done. 1 video left, I think. Bye.